Right, so we've just done a titration, and hopefully you've got three results that are really close together, what we call concordant. If you don't worry for now. The next stage is learning the calculations. There's a few steps for doing the calculations that are true for any titration, whether it's acid and base, like this one, acid with a base, or what we call redox, which is the one you're going to do for your internal, which is oxidation reduction. The first step whenever you're doing this is to find or write out and work out the balanced equation. The reason the balanced equation is important is because we're going to have mole ratios to work with. Remember that this balanced equation means that 1 mole of sodium carbonate reacts with 2 moles of hydrochloric acid to make 2 moles of sodium chloride, 1 mole of water, and 1 mole of carbon dioxide. That's what that actually means. But it's seldom will we have 1 mole and 2 moles. It's more likely to be 0.001 moles, that sort of thing. So we're going to need to use our ratios that we hopefully learnt in maths. After you've got your equation, we're going to turn it into a grid. And that's what I've done here. And I've got N, C, and V, amount, concentration, and volume down the left-hand side of my grid. I like to have N at the top because this is where I'm going to work with my mole ratios. I then go, which two things is this experiment about? It's actually only about sodium carbonate and hydrochloric acid. The rest I cross out. It's not important. So I'm not going to confuse myself with the rest of the equation, so long as the equation is balanced. Once I've done that, I fill in what I know, and this is the stuff in green. So my standard solution was 0.102 moles per litre. So you should note 3 significant figures, you put that in there. Your average titer, your 3 concordant results, I got 10.3 mils, but it's got to be in litres, so it's 10.3 over 1,000, or 0.0103. All right. I also know that I used 20 mils of my hydrochloric acid. So I'm going to put my 20 over 1,000 to get it into litres. I know these ones here. Well, I couldn't solve this column yet because there were 2 unknowns and 1 known. But this had 2 knowns and 1 unknown. Whenever you only have 1 unknown, you can solve something. So I know, hopefully remember this from last year, but we can always look it up, that the amount of something is the concentration times its volume. So I know the concentration and I know the volume. I multiply these together into 3 significant figures, but it's not exactly that. It's 1.05 times 10 to the negative 3 moles. That's the amount I've got. So not 1 mole, 1.05 times 10 to the negative 3. Well, if 1 mole needed 2 moles, then 0.1 moles would need 0.2 moles. 0.01 moles, because that's roughly 0.001. 0.0 moles would need 0.02, 0.001 would need about 0.002. So all I'm doing each time is multiplying by 2 because that's my ratio, 1 to 2. And I know that because of the big number. So whatever number I get there, I times it by 2 because the 2's in front of the hydrochloric acid to get this number. Again, to 3 significant figures, it was 2.10 times 10 to the power of negative 3. I only needed 3 SF. Our equipment isn't any better than 3 significant figures, so our answers can't be either. That leaves me the middle box, concentration, which is unknown, because I know it's 20 mils of hydrochloric acid. I now know how many moles of hydrochloric acid were in my flask. So, rearranging this equation, I get concentration as amount divided by volume. So I go this one divided by this one, and I get 0.105 moles per litre. Last step, I just need to get another pen, sorry. You might or might not remember way back, we diluted this hydrochloric acid by putting 20 mils into 200 ml flasks and making it up to the line. I did that enough to make our 2 litres for the class. So it was diluted by a factor of 10, 20 mils into 200. So this 0.105 moles per litre is the diluted stuff. The original must be 10 times more concentrated than that. So actually, my concentration of my original HCl from our lab stations, which said they were 1 mole per litre, is going to be 1.05 moles per litre. Now, that is 1 mole per litre. So what we've just proven is the stuff in our lab stations is actually what it says it is, just a little bit higher. And that's okay, because we're allowed to have up to 2 moles per litre legally in our labs. So we're okay. If we'd found this was 2 point something, I'd have a bit of a problem and we'd have to dilute that stuff. So you've actually done us a really good service, thank you. You've found that our solutions that we give to our junior classes are indeed what they say they are, 1 mole per litre. That's us.